Hi, sixth graders. We're going to do lesson 9.2 and 9.3 together. So 9.2 is sample spaces and 9.3 is fundamental counting principle. So our learning targets are being able to find sample spaces and probability and being able to use multiplication to count outcomes and find probability. So label your page accordingly with your lesson number and title. And then you can write this word down in your notes called sample space, which is a set of all possible outcomes in a probability experiment. So you'll want to write this down, maybe underline sample space. So it's all the outcomes that could happen in a probability experiment. So if we have this problem, the animal shelter has both male and female Labradors in yellow, brown, or black. Find the sample space for all possible Labradors available at the shelter. So we can see, or we know that we can get a male or a female, and they both come in yellow, brown, or black. So for each male, we have the option of a yellow Labrador, a brown, or a black one. And for a female, we have the option of a yellow, brown, or black. This right here is called a tree diagram. You don't need to write this down, but you do need to know what a tree diagram is. And we're going to be doing a few more, and you're going to be creating one. But this is how we list all of the outcomes or the sample space for our problems. And then these are all of our outcomes. So we can pick a male yellow, a male brown, a male black, a female yellow, a female brown, and a female black. So the total outcomes, the total number of outcomes is 6. 1, 2, 3, 4, 5, 6. The probability of picking a male brown is, well, there's only one male brown, or one option with male brown, but there's 6 options, so the probability would be 1 out of 6, or 1/6. The probability of picking a female, well, there's 3 options that include a female. It doesn't say what color, so that would be 3/6, which equals 1/2. So the difference, the total number of outcomes, is how many options you can pick from. The probability then is whatever the probability is that you're looking for, or whatever the option is that you're looking for, out of, so how many of those out of the total number. If there's a pair of brown or black sandals that are available in sizes 7, 8, or 9. Here's another example of a tree diagram. You can pick brown or black, and they both come in 7, 8, or 9. 7, 8, or 9. So we know then that we can have brown 7, brown 8, brown 9, black 7, black 8, black 9. So again, we have 6 different outcomes, and say we're going to find what's the probability of picking a brown sandal in a size 9 would be 1 out of 6, because there's only one option for brown 9. So 6 outcomes total. So because we know that this is 1, brown 7 is 1, brown 8 is 1, brown 9, black 7, black 8, black 9. Amy is trying to decide what kind of sandwich to make. She has 2 kinds of bread, wheat and sourdough, and she has 3 kinds of lunch meat, ham, turkey, and roast beef. Make a tree diagram listing all of the possible sandwich combinations. So I want you to pause me right now and create a tree diagram for this situation. So she can either pick wheat or sourdough, and she can go with ham, turkey, or roast beef. And then also for sourdough, she can go with ham, turkey, or roast beef. So there's, again, 6 possible combinations. probability of her picking wheat would be 3/6 because there's 3 sandwiches that include wheat bread, or 1/2. Probability of her picking a sandwich with turkey. We have wheat turkey or sourdough turkey, so that would be 2/6 or 1/3. Okay, Marcos tosses a coin and then rolls a dice. If the coin shows up heads and an even number is rolled, Marcos wins. Otherwise, Kara wins. Find the sample space, then find the probability that Marcos wins. Okay, well, these are each of the outcomes. So first of all, the first thing that he does is tosses a coin, and he can get a head or a tail. Obviously, those are our 2 outcomes. Then he rolls a dice, and he can get a 1, 2, 3, 4, 5, or 6. So he can get a head 1, H2, H3, H4, and so on. So it says if the coin shows up heads and an even number is rolled, Marcos wins. So heads and 2, that's an even number, so Marcos would win. H4, Marcos would win because it's a head and an even number. And H6, Marcos would win. So we know that if we get a head and then we roll a dice, we have 6 outcomes here. 1, 2, 3, 4, 5, 6 with our head. So 6. And then if we flip a tail and then we roll a dice, we still have 6 outcomes with that too. So our total number of outcomes would be 12. Well, Marcos only wins if it's a head or an even number, which we figured out is just 3 of the options. So Marcos has a 3/12 chance of winning, which would be 1/4. And then Kara would have we could either count up the rest, or we know that they have to equal 1. So if Marcos has a 3/12 chance, Kara would have a 9/12 chance because 9 plus 3 equals 12, and 12/12 equals 1. These would be a situation of complementary events. So then 9/12, we can divide both our numerator and denominator by 3, which would be 3/4. So Kara has a 3/4 chance of winning. And again, we can check. 3/4 plus 1/4 equals 1, because our probabilities need to, if we have complementary events, they need to equal 1. So Kara has a better chance of winning than Marcos. Okay, this is something else that I want you to write down in your notebook. The fundamental counting principle. I want you to write this down in the blue writing. If an event M has M possible outcomes and event N has N possible outcomes, then event M followed by event N has M times N possible outcomes, which looks and sounds super confusing. So let's talk about that. So write that down. Okay, so here's our example. Find the total number of outcomes when a coin is tossed and a dice is rolled, which is exactly what we just did. And remember, we had 2 options for our coin because it could be heads or tails. And then we had 6 options for our dice because it could be 1, 2, 3, 4, 5, 6. What we can do is we can multiply 2 times 6 to get 12. If we go back to here, really what we were doing is we were taking 6 plus 6 is the same as 2 times 6, because for each head we had 6 options and for each tail we had 6 options. So we really could just multiply 2 because our coin had 2 outcomes and our dice had 6 outcomes. So if the jean shop sells skinny, flare, and bootcut jeans, they come in sizes 2, 4, 6, 8, 10, and 12, and they are offered in short, regular, and long lengths, find the total number of possible outcomes. Well, we have the style is skinny, flare, and bootcut, so 3 different options. The sizes are 2, 4, 6, 8, 10, and 12, so 6 different options. And the length is short, regular, and long, 3 different options. We could, for surely, write out or make a tree diagram with our skinny, flare, and bootcut, and then we could have our arrows going to all our different sizes for each one, and then we could have our arrows going to each of the different lengths for each size. So it would kind of get to be a really big tree diagram, but you definitely could do that. But an easier way is just to take the number of options for style, the number of options for size, and the number of options for length, and multiply them together. And we get 54 total outcomes. So 54 total different jeans that we could pick based on style, size, and length. A store advertised that they have a different t-shirt for each day of the year. The store offers 32 different t-shirt designs and 11 choices of color. Is the advertisement true? So what we can do is we can take 32, because there's 32 different designs, and 11 choices of color, so we're going to multiply them together, and we get 32 times 11 equals 352. Well, it's asking us if the advertisement is true, and since it advertised that they have a different t-shirt for each day of the year, we know that 352 is less than 365, which is the number of days in a year. So the advertisement is not true. It is false. So you can only get 352 different types of t-shirts, not 365. Find the number of possible choices for a 4-digit PIN number if the digits cannot be repeated. So I like to, for a PIN number, we know that it's going to be 4 digits, and we are going to multiply each of our outcomes together. So our first choice of numbers is 10 because we're including 0 and we're going up to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 options for our first number. If the digits cannot be repeated, that means we just used 1 in our first number, or our first digit. So then we only have 9 left. And then we use another one and we only have 8 left. And then we use another one and then we only have 7 left. So 10 times 9 times 8 times 7 equals 5,040. 5,040 possible different choices for a 4-digit PIN number. Find the number of possible choices for a 2-digit password that is greater than 19. So we're going to do the same thing, 2 digits. So here are my 2 digits, and I'm going to multiply them together. For my first digit, it has to be greater than 19. So we know that that first number has to be 2 or greater. So it can be a 2, 3, 4, 5, 6, 7, 8, or 9. So that leaves us with 8. And then it says just greater than 19. So our next number can be any number. It doesn't say that it can't be repeated. So then we're back to 10 digits for our second number. So then we have 80. Okay, a few more examples. So use the fundamental counting principle to find the total number of outcomes, tossing 4 coins. So each time we toss our coin, we are going to count the number of outcomes that could occur. So each time we toss a coin, it could be a heads or a tails. So each time we have 2 different outcomes. And we toss it 4 times. So it's 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16 different outcomes of tossing 4 coins. Meaning you could get head, 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 tail, head, tail, head, tail, 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 and so on. The number of outcomes of rolling 3 number cubes and tossing 2 coins. So we have 5 different events going on. Each time you do something, roll a cube, toss a coin, that is called an event. We're going to multiply all them together. So if we roll 3 number cubes, so we have 6, which is basically just a dice, 6 outcomes each time of rolling our dice. And then tossing 2 coins, we have 2 outcomes because we could get heads or tails. Our dice, we could get 1, 2, 3, 4, 5, or 6. So then it's 6 times 6 times 6 times 2 times 2. And we get 864 different outcomes. And then our last example, John is taking a true or false test that has 6 questions. How many ways can the test be answered? So for each question, we are going to count how many outcomes. So see how I'm looking at the number of questions and then looking at the number of outcomes from there. So for each question, we're told that it's a true or false test, which tells us that there's 2 options for each question. So it would be 2 times 2 times 2 times 2 times 2 times 2 times 2. And we would get 2 times 2 times 2 times 2 times 2 times 2 equals 64. If the test was a multiple choice test, we would do, and we still had 6 questions, think about what you would put in these blanks instead if it was a multiple choice test. Oh, and I can't really count because I left 7 blanks instead of 6. Okay, so if you said that you would put 4, because I guess I didn't specify, but usually multiple choice test questions have 4 answers, then instead it would be 4 times 4 times 4 times 4 times 4 times 4. So see how it stays with 6 blanks or 6 events, because each question is an event, and then based on how many questions, it changes the number that we multiply by. And then, so it'd be 4 times 4 times 4 times 4 times 4 times 4, and then whatever that would equal. Okay? So make sure you log into NICU and take 9-2 and 9-3. It's only one quiz. It's together because we put the 2 lessons together. You can always look back in your book for more examples, and you can always re-watch the video. Make sure you have your math notebook for class tomorrow, and have a super evening.